think. Let me full screen it, then I can start. Okay, so first I would like to thank the organizers for the invitation. Today I will talk about the ZC and other charged charmonium-like states at BES III. So in this talk, basically I will go through all the studies, almost all the studies related to the ZC and other charged charmonium states. So I think maybe quite of those results are already familiar with you, but anyhow, I will introduce them in order. Oh, sorry. Okay, so my talk, the outline of my talk is as following. First, I will give a very short introduction of ZC states, and then I will introduce the new studies of the ZC decay modes, and then finalize it with the observation of ZCS 3985. So I think the motivation to study the ZC states is quite obvious, that we want to find the exotic hadrons which are beyond the configuration of the conventional hadrons. So those hadrons with exotic configurations, and yeah, this is the very simple motivation for those studies. And here I summarize all the ZC states that has been observed from different experiments. So I think till now there are about 12 ZC states observed from basically two production mechanisms, one from the electron-positron annihilation and the other from beef level hadron decays. And interestingly enough is that those states observed from the two production mechanisms do not overlap. So those seams do not overlap. So those observed from electron-positron annihilation was not observed from the other production mechanism, vice versa. So those states are almost all observed in the final stage, contains a pair of open charm meson or charmonium states together with few light hadron. So the understanding of the nature of these states need more study about the production and the decay of those states, as well as more precise study of their properties. So the study at BES III are using data samples taking above the 3.8 GeV and up to 5 GeV. So in total, we have 46 data samples with total integrated luminosity of about 20 events per bar. And among them, 90 to 29 data points, there are relatively large statistics, which allows to study the intermediate states in the final state systems. And we also have relatively small scan data samples all over the region. And I think I don't need to introduce the BEPC2 and BES III detector. So the studies I will present are based on those data samples or part of those data samples. And the study of ZC or the observation of ZC at BES III starting from 2013 with observation of ZC 3900 in the final state of pi plus pi minus J psi. It was also observed in DD star final state as shown here, and the neutral pattern of these states has also been observed in the neutral final state as shown here. The quantum number of ZC 3900 has been studied using partial wave analysis in the pi pi J psi and pi 0 J psi mode, and the quantum number is determined to be 1 plus, and from the amplitude analysis, and in the pi 0 J psi mode, data samples taken at different center of mass energies are used to perform the partial wave analysis. And besides the pole position of this ZC 3900, the production of ZC 3900 with dependence of the center of mass energy has also been investigated as shown here, where the cross-section shows a structure around 4.2 GeV, which agrees if we fit the cross section with a Brod-Wigner, the parameters agrees with the Y4230 observed in other decay modes such as pi-pi-GSI and pi-pi-HC. And the heavier partner of ZC3900, ZC4020, was observed in pi-pi-H sub C and D study star mode, as well as the neutral partner of this stage. Till now, there is no official partial wave analysis published for those studies, but we are still working on this with full data sample, which we already collected as shown before. So as for the final state of pi-pi-Psi 2S, the situation seems to be much more complicated. And here we show the cross-section measurement of pi-pi-Psi 2S as a function of the center of mass energy. And in the using the data samples which are indicated with this black arrow, where we have relatively large statistics, the intermediate state of pi-pi-Psi 2S system has been investigated for different center of mass energies. And we can see that the situation is quite complicated here in this mode. It is not easy to fit the data with very simple assumption. And for this final stage, there are also current partial wave analysis of this mode. And I think we also need much more consideration of the dynamics in this mode, and as well as theoretical inputs. And then I will go to the new decay modes search for the ZC states. The first is in the final stage of the rho eta C, and this mode has been predicted from the decay rate of this mode has been predicted from in different framework from the tetraquark molecular picture. So the ratio of this ZC decays to rho eta C with respect to pi GSI or pi H sub C it can be used to identify different intrinsic structure of the ZC states, as we can see here, the predicted value from different theoretical works, and the measurement here shows the invariant mass spectrum of rho eta C at one energy point with integrated luminosity of 1 events photobar, and there is an evidence of rho eta C. And the measured ratio is more closer to the tetraquark model, but we can see that the theoretical predictions varies in a very wide range, so there is no solid conclusion currently. And this study can be can be updated using much more data samples, which has already been collected. And the other final state related with eta C involved are also being studied. One is with ZC decays to pi eta C or eta C, and using the decay mode of eta C, eta pi pi. 2 data samples has been used in this study, and no signal has been observed in the final stage. Subsequently, no ZC structures in the final stage. Final state of pi eta C and eta C. The upper limit for the cross-section of this process has been set, which also apply for the ZC search. And another study related to the to eta C in the final state is to study the eta C in company with 3 pion, a pair of pion, or pi zero gamma, and the 3 final state has been studied, and only in the first final state where eta C is accompanied with 3 pion, we see quite strong evidence of the signal in the in the cross section, as shown here, where there's 3 pion eta C, the significance at 4.23 is about 4.6 G sigma. So the intermediate state has been studied only in eta C 3 pion final state at 4.23, and the ZC decays to eta C pi, a charged pion and a neutral pion has been studied in search for a ZC state close to the DD bar threshold. And here shows the search for ZC such a structure in different assumed mass as well as different assumed total width of this state. And in the first row where the ZC is charged and it decays to eta C together with a charged pion, and the second row shows the cross-section of ZC 0 decays to eta C pi 0, and the cross-section together as well as the upper limit of the production cross-section in different assumed mass of this ZC state, as well as different assumed total widths are given in this plot, and there is no evidence signal for this ZC structures decays to DD with a mass close to DD bar threshold, and in some mass there is some evidence, but this is not strong enough to draw any solid conclusion. And another search is performed in the final state of pi KCJ in search for the intermediate state of pi KC1, which was observed at Bell using BE decays. So the study the final state is pi KCJ, and in 3 KCJ final state, we did not observe obvious pi KCJ signal. And here shows the cross-section and the cross-section upper limit for the E plus E minus go to pi KCJ. And since we don't see any signal, so there is no signal of the intermediate state of in pi KCJ system. And then the last decay of the ZC was done in the relative decay to gamma X 3872, which was predicted to be several per mirror level, and it found that it will build connections between ZC and X state in molecular picture. So the study has been performed in the final state where the ZC 4020 is accompanied with a pi 0 and then decays to gamma X 3872. And the reconstruction mode for X 3872 is pi GPSI. And here we see the environmental mass of gamma X 3872, and the region below between this blue arrow shows the signal region where we do not see we do not see data in this region. So the upper limit has been put for this product. So which is consistent, which do not contradict with the theoretical prediction. And then I will go to the observation of the ZC 3985. So the study has been performed using data sample taken above 4.6 GeV and using the final state of KDS D star or KDS star D0. A partial reconstruction of the process has been used where only the bachelor cation and the DS has been tagged and reconstructed. So the DS is reconstructed with 2 modes, one with one to KK pi and the other to K short pi, and the remaining particles in the final state are searched for using the recoil mass spectrum. And here shows the environmental mass of KK pion and K short K, where we can see very clear signal of DS. And after applying the mass window requirement for the DS and check the recoil side of this K DS, we can see there is a very clear peak around 2 GeV. And for the first mode, this should be this in the recoil mass, this should correspond to the D star 0, which is a quite narrow structure. And for the second mode, it is a broad structure due to the missing of the photon from the DS star. And by selecting a mass window around this peak region, we can select signal events from both channels, and the combinatory background has been described by the wrong sign event, which are showing with the green histogram, and the absolute contribution of this combinatory background are fixed later on in the fit to the recoil mass of kaons, and the fixed ratio is determined from the fit to this spectrum. And after the above previous selection, then the recoil mass of kaon has been investigated. Here, the combinatory background has been subtracted, where we can see an enhancement close to 3.98 GeV, and dedicated studies has been performed and confirmed that this structure cannot be described by the process containing excited D mesons such as DS or excited DS star or or excited D mesons, and the possible interference between two of those states, two open charm process, has also been studied, and it is found that the interference between two open charm process cannot reproduce the structures observed here. So simultaneous feed has been performed to the spectrum obtained from the 5 data samples with assumed structure, assumed resonance. The quantum number is assumed to be 1+, and the signal component has been described by this formula where the 2 decay modes of this ZCS has been taken into account, and the pole position determined from the feed is listed here. The significance of the ZCS 3985 is determined to be above 5 sigma. So it contains at least 4 quarks, and could be the strange partner of ZC 3900. And in comparing this ZC 3985 with the ZCS 4000 observed from the HCB, we can see that the mass are consistent within one standard deviation, and the width is differs significantly, and definitely more investigation should be put from both experiment, and at BES III we should also study the structures in KKGSI final state. And it is interesting to mention that using the ISR technique, Bell studied the KKGSI process, and in the KGSI emergent mass, it seems there is no very clear structure, but the statistics is not very high, and this can be further improved in the future experiment. So here is my summary and outlook. So we have, at BES III, we have unique data samples from 4.0 to 4.95 GeV, and would provide opportunities to study the ZCS and to search for the new decay modes, as well as to study the production cross-section. So the several new decay modes has been studied, and unfortunately, no obvious signal has been observed for all of them. And we observed a new ZCS state in DSD star and DS star D mode. The significance is about 5 GeV, and we are currently also analyzing the neutral pattern of these states, as well as studying other decay modes. So we are performing studies related to these topics, and we expect more results about the production and decay of ZCS from BES III in the future. Yeah, that's all. Thank you. Oh.
Okay, thank you, Yuping.
Oh,
please raise your hand. What? Hello?
Hello, can you hear me?
Yes, I can hear you.
Ah, I see.
Okay, then please raise your hand if you have any questions.
我接电
Yes,
话。
Elisabetta?
I have a remark, actually, more than a question. I mean, first of all, let's congratulate the BES III colleagues, because at every conference or workshop, they are flooding us with so many interesting results. Another point is, I mean, what we understood if we put all this together about the models. I found interesting you're trying to find a connection between Z and X, because BES III already established a connection between the Y and X, between Z and Y, but still Z and X, you're analyzing now Z to gamma X is missing. Is there any plan, maybe other channels that you're planning to analyze, something that you can say to us?
You mean the connection between Z and X?
Yeah,
Or
yeah. This you searched here, but no signal found. You have just this upper limit. If you can say something, I mean, some plan, which other channel you are planning to search for? Okay, still secret.
I think as far as I know, there is no specular studies
Okay.
in other channels. Yeah.
Okay, thank you. Anyway,
But I think we have limited combinations of this Z and X states. So
yeah,
yeah,
limited, but still so many, I would say. Your talk
yeah.
is an example on how much progress BES III has done in the past 2 years. Thank you very much.
Okay. Thank you, Elisabetta. I have a small comment, or please go to page 11.
This one.
11. Yeah, is this a mistake or something? I think you against ZC on your Feynman diagram, you have a pi plus and pi minus against ZC. Is this really? Or
Yeah.
this
So
is
when we search ZC to eta C, then the other side is pi plus pi minus. Then
so
this is ZC 0.
Ah. Then okay, then I understand. Thank you. Any other questions or comments? Okay, if no, let's move
Just
to
one
the
thing,
next.
you know, can you hear me?
Yes. Yes.
Just one comment about the slide 9. Maybe we should keep that for the afternoon discussion, because it's not easy to understand all those fit. I mean, just a note for the discussion in the afternoon, the slide number 9 of this talk.
Number 9?
Yeah.
Oh, yeah.
Doing
Yeah,
several,
right.
Yeah, this is quite difficult to understand for me. So maybe we discuss later. Thanks.
Okay, yeah. Thank you.
Okay.
So I can stop sharing.